This is class 10 mathematics NCERT book exercise 1.3 question number 3. As we proved in previous two questions, in the first question we proved root 5 is an irrational number. Same way we can say root 2 is also an irrational number. That is, these are the theorems, and using that we can prove all other rational and irrational combinations are also irrational, as you saw in question number 2. Now this is question number 3. We have to show that this is an irrational number. So let's assume that first of all, this can be rationalized 1 by root 2. Rationalize the denominator. For that, multiply numerator and denominator by root 2 by 2. This we have rationalized. Now we can assume that, let's assume that root 2 by 2 is a rational number. Our question is prove that 1 by root 2 is an irrational number, but instead of taking 1 by root 2 we have rationalized it. This is the rationalization, and 1 by root 2 is the same as root 2 by 2. So we have assumed that root 2 by 2 is a rational number. Therefore root 2 by 2 can be written as p by q, where p and q belong to the set of integers and q is not equal to 0. But this can be again explained as when we transpose this number by cross multiplication to p upon q. So here once again we explain that here LHS is irrational but RHS is rational. This we can explain. How it is rational? Because the numerator is integer. Because product 2 is an integer, p is also an integer, as we mentioned here. The product of two integers is an integer and denominator q is also an integer. These are the two conditions for a rational number. And third condition, that q should not be equal to 0. This is not 0 as we mentioned here. So this is a rational number, this is irrational. So LHS cannot be equal to RHS. But they are equal because of our wrong assumption. So we can say that is our assumption is wrong. So you can say 1 by root 2 is an irrational number. In the same way, we can continue with second part, that is 7 root 5. This we can represent as p by q, where p and q belong to the set of integers, q is not equal to 0. Then transpose this number 7 p by q, it becomes 7q. So once again we can explain here root 5 is an irrational number. Like in the previous question also, root 2 is an irrational number, that is a theorem. So that we have applied here, so we need not show separately that these are irrational number. Root 2 and root 5 are irrationals. So that can be applied to prove these properties. Root 5 is equal to p upon c 7q. So here we can say LHS is irrational and RHS once again it's coming rational. How rational? Because it's integer and denominator is integer and denominator is not equal to 0. All the three conditions of a rational number are satisfied here. So RHS is rational, LHS is irrational, therefore LHS is not equal to RHS. So therefore our assumption is wrong. So 7 root 5 is an irrational number. Third part is 6 plus root 2. 6 plus root 2, in the same way we write equals to p by q. P and q belong to the set of integers. Q is not equal to 0. So this can be written as root 2 equals to p by q minus 6, that is equal to p minus 6q upon q. So we can check these two. Here LHS is irrational and RHS is rational. How to explain it? In the same way as we did above, p minus 6q is an integer because 6 is integer, q is integer. Product of these two is integer and difference of these two integers will be integer. So numerator is integer, denominator is an integer, and denominator is not equal to 0 mentioned here. So all the three conditions of a rational number are satisfied. So RHS is rational, LHS is irrational. So LHS is not equal to RHS. So our assumption is wrong. With this assumption we are getting they are not equal. That means that is contradictory to this. So we can say 6 plus root 2 is an irrational number. Here we can write, we can start the question by stating let 6 plus root 2 be a rational number, as we did in the first part. Second part also we can write here, let 7 root 5 be a rational number. Then write this step. In the first part we have already shown, let's assume this is a rational number. In the same way we can write in the second part and also in third part. That's all.